In this video, we'll be looking at a few of the key concepts behind Industry 4.0. And essentially, when we talk about some of these concepts, a word that gets thrown around a lot is disruptive technology. And the basic idea behind disruptive technology is emerging technology which displaces or removes an established technology that's there. It disrupts the way we do things. And there's many different examples of disruptive technology. Thinking back a few decades, one of the big pieces of disruptive technology was digital cameras. And before then, we had Polaroid cameras, instant cameras, or we had film-based cameras. And these digital cameras came along and people wrote them off at first because the quality wasn't very great and things like that. But eventually it got really good. And I had a digital SLR and I had an SLR. I never used the old-fashioned SLR because it was too expensive to develop films and too much of a hassle, and you couldn't see what you'd taken until weeks after. With my digital SLR, I can do all that straight away and see what's going on. And these days, even wedding photographers will use digital SLRs for most of their photography. So this is one form of disruptive technology, but we've got many others. Mobile internet, mobile phones, smartphones are a major area of disruptive technology. Things like Internet of Things, robotics, cloud computing, 3D printing, they're ideas that shape and change the way we do prototyping and manufacturing and connectivity and all of these sort of things. They change the scope and change the way that we can make things and change the way that we can actually work in a physical sense. And digital transformation is one of the things that's actually brought this about. The idea is that there's a lot of manufacturing companies that are really digitizing themselves. They're turning into more digital organizations with smart manufacturing. So no longer did they just have a whole bunch of milling machines or lathes or wordjet cutters or whatever, and someone would send them a design and they'd draw it up by hand and then they'd have someone do everything manually. The idea is that nowadays these have a large digital component to them. So people can submit their designs online. All their equipment's always online. They can upload live data. That data can be analyzed. If it passes a whole series of checks and balances and risk management, it can go straight off to manufacturing. One place that this might be the case is if you're a company that manufactures USB sticks and has maybe some custom writing or something on them, so a company can have their logo on it. Well, if you upload your logo and say, I want 500 of these or whatever, that could go, the person could be billed straight away and that could go straight into production. It could print their logo on there or laser sinter it or whatever technique they use and hence send it straight into production. And a person need not actually touch them from the point that it actually goes into the machine to the point that it comes out and goes in the box and goes out to their door. This digital transformation has got huge gains in efficiency. And one area that people are suggesting there's huge gains in is if you want a one-off of something. Previously, if you wanted a one-off USB stick or t-shirt that's custom or something like that, it was hugely expensive because there was a massive setup time involved and the overhead of dealing with someone and all those sort of things. Nowadays, if you say, I want one of these USB sticks, it's still more expensive, but it's starting to head in this direction that you enter all your details online, press go, and a person doesn't actually touch it until it comes off the machine into a box and they stick it in the post to come to your door. This is the sort of way this is heading and will mean that we'll be able to have customization at a very low cost. And that's one of the hallmarks of and plans behind the Industrial Internet of Things or Industry 4.0. The other thing is not just in actually manufacturing these things, but actually getting data off all our machines and things like that. So with this smart manufacturing, we'll be able to send all our designs to our machines automatically, but also doing predictive maintenance on the machines. If they've got dozens or even hundreds of sensors on them, we can work out whether it's working in its optimum way, whether the heads are starting to wear on there or bearings are starting to wear or the oil needs topping up. All of these things, we can feed that data back into how we maintain the equipment and how we maintain our factory and how we optimize our factory. Now, cyber physical systems are another term that's used around this Industrial Internet of Things area or Industry 4.0. And the basic idea is a lot of these Industrial Internet of Things areas consist of both cyber elements, so things that are performing computation, the networking, control, the sensing, the computer elements, and physical elements. our mechanical devices, our infrastructure, our milling machines, the people that are actually using them. And we're developing systems that integrate both of them. So we've got physical systems, we've got embedded systems that are controlling those physical systems, and we've got the communications and IT systems that are running all that together. And so we've got our information technology, the IT, and the operations technology, what that information technology will actually be controlling and optimizing and running over a period of time. So cyber physical systems really enable these things to actually happen, and to leverage off all the sensors and things that we've got in our operational technology through our IT backbones and our IT sort of networks. And so here's some of the technologies and the path that we've come along. We think originally we're talking about just embedded systems, sticking a microcontroller on something and reading some data off, and then we move to smart sensors. And those smart sensors will give us data about the state of something and help us to actually make some changes based on that. And then we move to smart systems, where we've got an actuator and a sensor, and we use those smart sensors in concert with the actuator to actually do something. Then we come to cyber physical systems, where we do that on a much larger scale, and we'll typically put that data on the cloud and things like that. And then we've got cyber physical production systems, where this is what our whole factory looks like. Everything's networked, everything's connected, and everything, we have data on everything and the state of everything and how it's all working and what's actually happening. So this is where we have our smart factories. Digital twins is another really important concept, and it's something that's come about with cyber physical systems. And basically the idea is that we create a cyber version or a simulation version of our real system and have them connected together so that as our real system's operating, it's sending it all its data to this cyber version of the system. And so we can use this to perform, for example, predictive maintenance. When our cyber physical system, when our cyber twin is starting to wear out, or something might be wearing, or something might be going wrong, we can say, oh, we might need to do something on our real version before it actually goes wrong. And we can extrapolate this data into the future as well and work out when that maintenance needs to be performed. We can look at optimizing processes as well. If we want to optimize something and change something, we can try it out first on our digital version, on our cyber version. And if it works, we might roll that onto our real version and use it in there. But it might not work the first time or second time or third time. Rather than taking our real equipment offline, we can use our cyber version, very inexpensively perform all that testing, and then use it on the real version once we're actually happy with it and once it will work reliably. And so through our Internet of Things or Industrial Internet of Things backbone, our digital system can be connected to our real system, our cyber, to our physical, and we get all the data off the physical, informing the cyber version about the state of the system and what's happening. And we can have a nice little visualization like we have here of what's actually happening in that system, and in this case, a particular engine.